Hello everyone, my name is Timothy Lee Grant. So yesterday I was working on this problem. It is number 102 on Leetcode, binary tree level order traversal. So I'm trying out to do a different methodology of learning Leetcode. And the way that I'm trying to do this is no longer where I just try to solve a problem. That's what I was doing in the past. I was going in trying to solve the problem, and then I would get frustrated that I didn't solve it, and then look at the answer, but then I wouldn't actually study the answer. Now I'm flipping that around. So yesterday I went and I'm doing trees, okay, the tree section, and I stumbled upon this problem and I wasn't able to solve it. Okay, so I went right to the solution and went and tried to understand it as best I could. Okay, so now what I'm going to do is today I'm going to try to solve it again. And in particular, what I'm trying to see is number one, am I able to solve it? But if I'm not able to solve it, that's okay. What is my stumbling points? So trying to go and actually identify, okay, hold on, I knew it yesterday, or at least I kind of understood it yesterday. Then I come here today. What stumbling points did I have? Write that down on my little piece of paper, right? Note that, then dig into it. Like, okay, well, why was I confused about this? What does the does this have other implications? Like, am I going to, is this a larger problem that maybe I need to back away from this or this problem number 102? Maybe I need to, or I need to go and deal with the bigger problem, right? So trying to understand, okay, where are my stumbling blocks? And the reason that I gave myself a day, so from yesterday to today, is because, okay, it gave my brain a little bit of time to forget, and that way it will really allow me to find out, like, okay, well, I didn't understand this part of the problem. So that's what I'm going to try to do now, is solve this problem. And then after I do that, okay, well, if I'm able to solve this problem, that means that, okay, it's time to go and look at some of the other problems within trees and then try to make connections between this problem 102 and maybe 535, right? Like, okay, well, here are two tree problems. What are the connections, and abstracting that away? So let's come in here. I already last night, went right when I finished this problem, I pressed the clear button, and so it's all clear. So let's read the question and try to figure out how to do it. All right, so number 102, binary tree level order traversal. Okay, level order. So some observations that I'm going to continue to make is there's level order, there's in order, there's pre-order, and then there's also depth first search, breadth first search. Okay, so how are these all playing together? So I'm gonna actually write that down. Like, how does breadth first search and slash depth first search play with in order, pre-order, post-order, in pre-post order traversal. Okay, and then now I have level order. Now, where does level order fit in? Okay, so that's one question that I have, and I didn't think about this yesterday. Like, what's its connection to depth first search, breadth first search, right? But now that I'm reading it again after I took a 24-hour period, I am coming into this and saying, well, wait, hold on. What is the connection? How are they related. Okay, so given the root of a binary tree, all right, so we're given the root, yeah, return the level ordered traversal of its nodes. So what that means is we have a node, and I want to create an array, okay? And in this array, I want each of the nodes in that level from left to right. So here's my root node, okay? And then the root node, let's say, has two children, okay? In this case, it's going to be 9 and 20. So the left child is 9, the right child is 20, okay? And so what I realized yesterday was in this problem, I need some mechanism by which I am able to keep track of what level I'm on. And the way that they did this, I looked at the answer, right? And what they did was, okay, they were using a queue. So Q equals DQ like this, okay? And then added the roots. So Q dot append and then root, right? And then they said while Q, so they continued while there was something in the queue, okay? Then they had the result is equal to an empty list. Okay, so now we set things up. We have this queue, and a queue is first in, first out, right? And I first put in the root. So I put in that root of the tree, okay? And now what I want to do is I say each time I hit this while loop, I actually want to process all of the nodes at that level, right? So I'm going to say level is equal to an empty list. And now this result is going to be this outer, the big list, right? Now this level is I'm going to add all of those all of the nodes which are part of that specific level. And each time I come back up to this while loop, I'm going to get a new level. Okay, so I want to process all the nodes in the level. Well, how do I do that? Well, what I need to do is I have a queue right now. So what is my starting point right here? When my program hits this location right here, what do I do? Or what state am I in? I am in the state where my queue has all of the elements of the current level, right? Because look, I just added the root, and the root is the only element on that first highest level. And that's the only element in my queue. So I want to process all of the nodes which are currently in that queue, but I don't want to process any extra nodes that I will be adding to the queue, right? So what I want to do is for blank in range length of queue. Okay, so now this is going to be static. This is going to look at it immediately and say Q is equal to 1, or the length of Q is equal to 1. And so I'm just going to do this one time, right? So I'm going to add things to my queue. What am I going to add? Well, which order am I going to try to add my nodes? I want to do the left one first because I want to put the left one in because I want the left one to be processed first, right? Like left and then right. And the reason for that is in a queue, I'm going to put the left and then the right here. And then it's going to process that out. So then we're going to get 9, which is the right child, or the left child, sorry. So I need a node though, right? So which I need to take away from my queue, right? So current node is equal to q dot pop left. So that means popping from the first index of my queue, which is exactly how a queue works. You just pop from the first. Okay? And so now I've gotten that first element. It's no longer in my queue, and here it is right there. Okay? Then what I want to do is I want to take that node and then process both its left and right children. So q dot append current node dot left q dot append current node dot right, but I need to check like if the left and right exist. So if this exists, then we do this. Okay. If this exists, if the right child exists, then we add the right. Okay. So now I'm going to keep doing this, and let's say that there's the next level, there was two children, and each of those children have two children. So the layer below that has four. So now what's going to come up here is I'm going to say, okay, great, I have a new level. I'm going to come here and I'm going to look at my queue and see that there's four elements in my queue. Okay, and this is just going to be a static number 4. So it means I'm going to process 4 elements out of my queue. Right now my queue only has 4. So that means when I get to the point where this terminates, where this for loop here terminates, I have processed all of the elements that are currently in my queue, even though I'm actually going to be adding extra elements in my queue. I'm not going to go and process everything. So my queue is still going to exist, but I'm just going to have new elements in there. So then I come here, I pop off 1 from the front, okay? And then I add the left and right to the back. And then I come back up here, pop the next one. So then I do the second like node. And then I add its left and right children to the back. So now I have the second nodes left and right in the back. Then I go to the third, then I go to the fourth, right? And now I have 8 elements in my queue, but I've already removed those 4 which were part of the level. Okay. And now I should, once queue is empty, that means that I no longer have any more elements that I can add because I've already processed all of them. I should be able to return result, right? No, once this for loop ends, I need to actually put that level inside of result. So result.append, and I want to append level. Okay, so let's see if that works. Current node dot left. Okay. Object has no attribute left. So how would it get to the case where current node doesn't exist, right? Because that's what's happening is current node we're popping essentially none, right? If current node left, then we So I'm protecting both the left and right here, so I shouldn't have added anything that was null. Okay. And I've popped each time. So the situation which we're in right now is I think I somehow got my numbers or the number of times that I hit this for loop or I added too many elements or yeah, there's something that I did wrong in which this pop operation seems to have popped a null, like an object of type none, right? So I popped null from my list. But if I have null here, it should have not run this. This is left and this is right. So, okay. Well, that means it is time to immediately come here and figure out what I did wrong. Okay. What did I do wrong? So what I'm trying to figure out now is was it just a silly little mistake that I overlooked? And if I did, if it was a silly mistake, okay, why did I overlook it? And why am I unable to figure it out right now, right? I looked at this over and I can't figure out why. So what's causing that problem? Okay. Or is it a function like a misconception that I have? Which in that case, okay, well I need to figure out what my misconception is. Um so level order traversal and a breadth first search. Okay. The issue is that you're not actually adding the current node's value to the left list. Oh, right. I never even add. Wait, is that true though? So level dot append. Okay, yeah, current node dot val. I know that I need to do that, but I don't see how that would solve the problem. Okay. Let me try to copy this. I don't know, did I lose internet or what? Oh, look at that. I need to sign in. Okay. Um, Darn. Okay, so, but I'm missing this level append here. How would that fix it though? Okay. Current node. So level dot append current node dot val. Oh, wait, no, I have that twice now. Yeah, it's not right. I knew that it wouldn't fix it. Doesn't make any sense. Okay, so that means I get to go to my previous submissions and see what I did that time. Range length Q, okay. Result.append level. If right, okay. If left. Well, interesting. Okay. So this doesn't make any sense at all. That's awesome. Um, so if root is none, it should just say that this is null and then return this. Let me see if that fixes it. If not root, return this. Does that fix it? Yes, it does, but okay, well, now I don't understand why. This line will run. If I add a null into my queue, but if I add none to my queue, then why would my while loop even run? So while q.append root is none, yes. Now, this condition checks whether the queue is non-empty, and it is. It contains one element, none. So then it comes here, pops the none, and then does, okay, fine. So it has one element, which is none. But does that mean that I will actually be adding nuns to the output? I guess no, I'm not adding nuns because if I get a none here, then I won't add it. So the only possible time that I put a none in my queue is at the very beginning, if root is none. Okay, so that's a case that I need to remember is I can't just assume that my none case will, how do I put that? That none will not trigger the while loop. Okay, and let me submit this, make sure that it's all good and happy. Okay, cool. So I think I did understand the concept of this. Now, the next thing that I'm going to be doing is maybe even these ones, who knows? Um, Going and trying to look at more problems within the tree section. I also need to, I think that the reason that this is breadth first search is because remember, depth first search, you go to a node and then you keep going down, 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 down until you've exhausted your pathway. But breadth first search, you have a starting point and you go to one, and then you say, okay, well, I explored this one. Then you go to the next one, which you were just on, right? So you kind of like spider out, which is exactly what we're doing. So stack, or not stack, sorry, queue allows you to do a breadth first search. So if I see something that wants me to do a breadth first search, that's level order. That is using a queue. Okay, I need to remember that. So breadth first search is a level order traversal, and I can use a queue to perform this traversal. Okay, there we go. So now, next step is to try to go and look at other problems and learn them, and then do essentially the exact same thing that I just did with this problem, 102, but with new problems, still within trees, and then once I understand multiple problems, try to find the connections. Or while I'm doing the second problem, find the connection. Okay, well, understand this second problem and find the connection to this 102. Then when I do a third problem, okay, well, understand this third problem and what is its connection to problem 2 and problem 3. So that's how I'm trying to do these Leetcode problems. I feel like this strategy for Leetcode is significantly better than what I was doing. You can go back and watch my videos. I've been struggling with Leetcode for a very, very, very long time. I felt like I couldn't understand it. I was horrible at it, and I felt like it was just impossible for me. Now I feel like I'm actually making significant improvement in Leetcode and able to make some progress. So I'm very encouraged by this, and I'm going to keep uh, using this process. I'm going to try to refine things, make sure that I'm able to become extremely optimal in my path. And so, if that's something that you are curious about, you want to join me on this leak coding process, you're trying to become better at Leetcode too, then subscribe to this channel and we can do this process together. I would love to have you on the journey. So, hope you have a wonderful rest of the day. My name is Timothy Lee Grant, and I will see you guys very soon.